My name's Adam Wathen. I'm a PHP developer full-time. I'm also the host of a podcast called Full Stack Radio. Has anyone ever heard of the podcast by any chance or listened to it? A handful of people, cool. I have a bunch of stickers and stuff, so if anybody is a sticker person and wants podcast stickers, come find me later in the day and I'll hook you up. So how many times have you started a brand new greenfield project and kind of said to yourself, you know, oh, I'm so excited to be working on this new project where we don't have all this legacy code and all this technical debt, and we can finally do everything right. You know, we're going to apply all these practices and principles, best practices that we read about online and that we see all these, you know, smart and experienced programmers using, and we're finally going to build this application that's going to be the perfect code base, and it's going to be so maintainable and so well designed. And you start thinking, okay, well, Patterns of Enterprise Application Architecture by Martin Fowler. I love that book. There's a lot of cool things I want to apply from there. We got to figure out how to incorporate some of those ideas into our application. Or maybe you're excited about domain-driven design and, you know, aggregate roots and entities and value objects, and you want to figure out ways to kind of separate all your, you know, infrastructure from your actual business logic using some of these principles. And maybe you've read Growing Object-Oriented Software Guided by Tests, and you want to learn how to do test-driven development and Maucus TDD and all this stuff and apply that to your application. Or maybe you watched Uncle Bob's presentations on the clean architecture and figuring out how to use hexagonal architectural principles and ports and adapters to kind of keep everything isolated and separate from each other. Or maybe you want to apply CQRS and event sourcing to your application and make sure that, you know, you're separating your reads from your writes, because you can't optimize for reads and writes at the same time, so you need two separate code paths. Or maybe you're excited about microservices and you want to split your authentication up into one service and you know, some other services up all over the place. And when you start seeing all these things piled on top of each other that you feel like maybe you have to apply to the next thing that you want to build, maybe you feel something like this. This is how I usually feel. So all this stuff is really exciting and interesting, and I know as developers who are really interested in, you know, getting better at what we do, we get excited about a lot of this stuff, and we're always looking for ways to improve our code and figure out how to design better systems that are going to be easier to maintain. And one person I've always kind of looked up to in this regard is Kent Beck. Is everyone familiar with Kent Beck, or is anyone familiar with Kent Beck? So Kent Beck is kind of the guy credited with kind of you know, popularizing test-driven development. He's written lots of great books and articles and stuff on programming. But the stuff that he always usually tends to talk about is stuff like this. So this is an excerpt from the beginning of Smalltalk Best Practice Patterns, where he says, you know, this book is about, you know, the simple things experienced, successful small talkers do that beginners don't. The topics covered are things like, how do you choose names for objects, variables, and methods? Or how do you break up logic into methods? Or how do you communicate most clearly through your code? He's never really talked about some of these higher level architectural principles like hexagonal architecture or CQRS or event sourcing. He's never really got into the kind of these higher level things, and I couldn't really find anything that he's written about this stuff, you know, stuff that we're all interested in learning more about, and I was really keen to get his opinion on this stuff. So I had the opportunity to interview Kent for the podcast, and I asked him this question specifically, you know, like, how come you're always talking about these low-level ideas and kind of the day-to-day, line-by-line sort of programming that you do, and not really talking about higher-level architectural principles? And this is what he had to say. He said, you know, I don't really see the difference. So whether you have two elements in a statement or two services in some distributed architecture, the principles are the same. And I thought this was really interesting, because what he's kind of saying is that design is kind of this fractal thing. And if you can get like the low-level design right, it's the exact same ideas and principles that you use to decide whether this service should be responsible for this or this other service should be responsible for this. Or figuring out, you know, should this object be responsible for this calculation or should this one be responsible for this calculation? It's the same sort of problem solving and thinking. So I thought that was kind of a really interesting way to phrase it. So I thought it would be interesting to kind of do a little bit of an experiment and stop worrying about architecture for a while. I'm not really thinking about any of these hexagonal architecture principles or things like that, and instead focus on how can I make the line-by-line code that I'm writing day to day that I see in my editor, those real characters, how can I make those as best as possible? And my hope was that in focusing on this stuff, that it would eventually bubble up into well-designed systems overall, as long as you focus on getting the small stuff right first. So I could go through like a bunch of slides of code examples and stuff like that, but it's kind of tedious to do in Keynote. So in the immortal words of Bill O'Reilly, we'll just do it live. Okay, so do I need to make this bigger? Maybe a little bit. Is that pretty good? So imagine we're working on this kind of imaginary like book purchasing platform where people can buy ebooks online or something and add them to their cart and check out. And one of the things people need to be able to do is apply coupons and get discounts. So I'll walk you through a little bit of simple code here and show you what we kind of have in place, and then talk about some new features that we need to add and how we might go about adding them and trying to keep this code clean as we do it. So here we have this order class, which represents, someone's like order that they're creating that they're going to check out and purchase. And an order takes in its constructor, an array of books that the person is ordering. It has this apply coupon method that stores a coupon on the order. And then here we calculate what the total cost of the order is by first checking, do we have a coupon? Well, if there's a coupon, then the discount we need to apply is going to be equal to the value of the coupon. Otherwise, they're not going to have a discount. And then we figure out the total price by initializing a total price variable, looping over all the books, and adding the price of every book to the total price. And then ultimately, at the end of the day, we just subtract that discount from the total price, and that gives us the total cost of that order. We have this coupon class now that all it does is take some attributes in its constructor and just, it's basically like a struct. It's just like a data structure. We don't really have any logic or anything living in here. I have some tests here for us to look at. So here we have a test to test that an order with no coupon is not discounted. So we have an array of books. These prices are in cents. So a $20 book, a $30 book, and a $40 book. We put together an order, and then we check at the end of the day that the total cost of that order is $90, which is just the sum of the prices of all the books. Let's zoom out a little bit to get this wrapping to not be so bad. The next test here is to test that a discount is applied when a coupon is added to an order. So we've got the same array of books, but now we're applying a coupon that's worth $10, and we want to make sure that the total cost of the order is now $80 instead of $90. So we can run these tests and with any luck see that they pass. Oh, so we got 2 tests, 2 assertions, everything's green. So imagine a new requirement came down the line where we needed to be able to support coupons that weren't just like some fixed amount off. In this case, any coupon we apply can only be like some dollar amount, right? Like $10 off or $20 off or something like that. Say we needed to be able to apply coupons that gave you like 25% off or 30% off or things like that. So how would we go about kind of implementing this? So I have a test that we can look at here. And we'll walk through kind of some first steps and see what we can do to keep things clean. So here we have a test to test that an order is discounted by a percentage when a % off coupon is applied. So we have the same collection of books. We instantiate this coupon, but this time we're adding this new property to the coupon saying, well, this is a % off coupon, not a fixed value coupon. We instantiate our order with those books, we apply that coupon, and then we make sure that we, in fact, got 30% off, which would bring us to a $63 order. So we haven't actually implemented this code yet, so let's run the tests and kind of see everything fail. So we get a failure saying that we got $89.70, but we were expecting $63. Because right now it's just subtracting 30 cents instead of 30%. So what's the kind of first kind of naive way that we could go about implementing this? So what we might want to do here is figure out, okay, well, where are we figuring out this discount? It looks like it's kind of this chunk of code here. So if there's a coupon in place, we calculate the discount by just getting the value of the coupon. But now there's kind of 2 possible ways to calculate this value depending on whether it's a % off coupon or not a % off coupon. So what we might do is we might add a conditional statement here, right? We might say something like, if this coupon is %, then we'll do one thing, else we'll do another thing. So the else is going to be the fixed value kind of calculation that we already had. But what are we going to do in this case? So in this case, it's going to be something like the total price of the books, right? Which we don't have yet because that's down here. So let's move this code up to the top so that we have access to that total price variable. So this guy is going to be equal to the total price, and now we're going to multiply that by the % off that we're supposed to be getting, right? So we can say something like this coupon value, and the value in this case is that 30, so 30%, and we need to divide that by 100. So if we run this, we're going to see it fail for a different reason, with any luck. So now it's failing because we don't have an is% property on our coupon. So if we go back to our coupon class now, we're going to need to set that in our constructor. So here we're going to have a property for is percent, which is going to be true or false based on whether it's supposed to be a fixed amount off or a percent off. And then in the constructor, we're going to do this is percent is equal to what comes in through this attributes array. This is just kind of, I thought, the simplest way for demonstration purposes to be able to kind of add some of these fields and stuff as we go and keep the code short, but you might not necessarily be passing in an array to a constructor all the time, but yeah. So back to our order class and our tests. If we run them again, what happens now? So now we actually get an error on the second test because is percent hasn't been defined. And that's because now we have to update our existing test to explicitly say, well, this coupon is not a percent off coupon. So we have to edit this test a little bit before we can kind of keep moving forward. If we run the tests now, everything's green. So we've successfully implemented the ability to have percent off coupons. But as you might imagine, this code is not exactly clear or clean, right? It's kind of like a big, long, jumbled method that's kind of ugly and has all sorts of scattered responsibilities happening all over the place. So let's talk about trying to clean this up. So the first thing that I think I would do here is trying to figure out, is there any methods that we can extract? So here, we're just trying to calculate the total price, right? So why don't we create a method for calculating the total price so we can move some of that code out of here. So let's have well, what is it? It's kind of like the gross total price, right? Because it's before applying the discount. So let's call it gross total. And let's just move this loop down into there. And return that total price. And spell it correctly. Always helps. And I'm going to run the tests now just to make sure we didn't make any weird syntax mistakes or anything before actually doing the extraction. Make sure everything's still green, and it is. So now we can actually replace all this code with just a call to that method to get the gross total. Run the test again. Still green. So we've cleaned up a little bit of this method. But now we have this whole chunk, right? And this is kind of the chunk that's responsible for calculating the discount. So let's extract another method for that. So here we'll have a private method called discount. And we'll just copy and paste this code in there and run our tests again to make sure we haven't done anything silly. So if we return discounts. So we're not actually calling this method yet, but I still want to run the tests again just to make sure that I know they were passing before we do the extraction. So we're still green. Now we can just say, discount, not for, $, equals this discount. And we're going to get an error here. And the error is because we have not defined this total price variable. It's a little small, but you can see here, we were relying on the total price here to determine the discount. So, you could do something like passing that in, but in this case, since it's calculated in this instance method, we can actually just call that method directly from here. So we can just say this, gross total. And now with any luck, when we run the tests, they'll be green again. And they are. So let's kind of just take a look at this class again and see what we think. So one thing that I think we can simplify a little bit here is these kind of temporary variables are not really buying us anything at this point. So I would just inline those into this little bit of arithmetic down here. And then we can kind of reduce this down to a single line, which is kind of nice. So if we just look at the kind of the public API of this class now, it just has this apply coupon method, which doesn't really do much except store that coupon so we can use it in calculations later. And the total method, which is quite readable and easy to understand, right? It's taking the gross total of the order and subtracting the discount. So if you're just another developer on the team that kind of wants to understand, well, how is the total calculated, and you're not really worried about the implementation details, you can come in and just look at the public API and think, okay, this is pretty straightforward. I kind of understand what's going on here. But if you dive down into kind of the implementation, things are still pretty hairy. So let's look at each one of these methods one at a time and figure out what we can do to clean it up. So this first one, where we're using this for each loop and stuff, there's simpler ways to do this if you're willing to explore some sort of functional programming ideas. So I find just about every time that you have a for each loop, what you're trying to do already exists as some sort of function that has a name. In this case, this is a functional operation called a reduce. So in PHP, you can't call methods on arrays, but there's a lot of collection libraries that allow you to call methods on arrays. And I have one pulled in this case, to kind of simplify things for us a little bit. So if in our constructor we wrap this array of books in a collection so we can actually treat it like an object and perform operations on it, then here in this gross total method, we can actually just do something like, well, what are we trying to do? If you were going to do this like, by hand, I think I might do something like, I have 10 books on the table or something, all with prices on them. I might look at each one, write down the price of each one on a notepad or something. So basically get the prices of every book and then just kind of sum those numbers all up together, right? I might do it in like a two-step operation like that. And we can actually model that in code by using a map operation. So we can do something like the total, the prices is going to be equal to this book's map. And what map lets you do is basically convert every item in an array into another set of items where you apply the same transformation to every one. So we can do that by taking the book and then just returning the price of the book. So what this actually ends up giving us is just a list of all the book prices. And now after we have a list of the book prices, we can calculate the total price by just summing the book prices, right? So we can just call prices and then the sum method, which just sums up all the numbers in that collection. So let's run the tests and make sure that we haven't broken anything. And everything's still green, so that's good. But looking at this, it looks like we can simplify it a little bit more, right? All we're doing is creating this prices temporary variable and then calling sum on it to determine the total price. So we can actually inline some of this. We can move this sum call just to right here. And now prices becomes total price. And that's a little bit shorter, and hopefully everything's still passing, and it is. And now this variable is like not really worth having around either. So we can replace this whole thing with just a return statement, run the test, and we're still green. Now this map operation where you're just trying to like extract one field from a list of objects or a list of data structures is really common, and a lot of languages and libraries provide the ability to do it in a little bit of a more terse way. And the library I'm using actually has an operation called pluck, where you can just pass it a string, which is the property that you want to extract. So here we're taking the books, we're plucking out the price from each book, and then we're summing the books' prices. If we run the tests again, we're still green. Conveniently, sum also takes the same parameter that pluck takes. So we can actually remove the pluck call entirely and just call sum and pass in the price. So now if we run the test again, we're still green. And now instead of like that 9-line function where we're initializing a variable to 0, looping over all the books and tallying them up and then returning it, we can just say, okay, take all the books and sum up the prices. And to me, this is like much more expressive and much more communicative of what we're actually trying to do. Instead of having to look at this loop and kind of parse out, why do I have this loop? What am I trying to do in this loop? What is the actual goal that I'm trying to accomplish? We can express that in what I think is a much more intention-revealing way using some of these kind of functional programming ideas. So that's a big win in that case. Now jumping down to this function, the first thing that stands out to me is this big, nasty nested conditional, right? So I don't like conditional code at all, and I like nested conditionals much less than I like regular conditionals. So let's figure out if there's anything that we can do to simplify this. So the first thing that stands out to me is we're trying to calculate this discount, and I want to figure out like what are the kind of the players involved in that? What's kind of necessary to figure out this number? We have whether or not the coupon is a % coupon, right? We have the gross total of the order, and then we have the value of the coupon. Those are kind of the three things that are needed to calculate this. What I think is interesting, though, is that 2 out of 3 of those pieces of data exist on the coupon class, not on the order class, yet we're doing the calculation in the order class. So when I run into situations like this, a lot of the time what I'll do is I'll experiment with moving the calculation to the object that holds more of the data and see if that results in a design that I'm happier with. So let's figure out how we can do that in this case. So it'd be nice if we could just do something like discount equals this coupon discount, and then it's probably going to need some data from the order that we'll have to pass in, but we'll figure that out kind of as we go. And now we can move this code into the coupon. So let's create a public discount function on the actual coupon itself. Just paste this code in. We're going to have to return this discount ultimately. And let's just comment this out here, or delete this, or we'll just run the tests and see what fails, because of course things are going to fail here. So undefined property app coupon. So we have to take all these references to this coupon, and now that we're in the coupon class, those are just going to be this, right? So if we just select all those, the only thing we're missing here now is this gross total thing. So if we run the tests, I think it's going to complain that there's no gross total method. So undefined method, gross total. So that's data that the order holds, so we're going to need to pass that in. So let's just pass in the gross total and accept it as a parameter here and replace this method call. And go back to our order class and pass that in. So we can say this gross total. Run the tests again, and we're green. So looking at the order class now, it's a little bit simpler. We remove the nested conditional, and the coupon is kind of justifying its existence a little bit more now because it actually has a job to do instead of just holding data. But there's some things that we can do to simplify this even further. So here all we're doing is setting this discount variable to either this value or this value and then returning it. So we can just return early and get rid of this temporary variable entirely. And now if we get rid of this return statement and run the test, we should still be green. And now since we're returning early, we can actually get rid of the else clause too, right? So if we get rid of this, pull this out, run the test again, still green. Now this is better. I still don't think it's perfect. The thing that I don't like about this is kind of the most interesting part of the code is kind of the most indented. I try and keep like the happy path or kind of the expected path as far to the left as possible and try and only handle more edge cases and exceptional cases like in conditionals and things like that. In this case, I think this would actually read cleaner if we reverse this conditional and moved the return 0 line inside of it and treated it more like a guard clause. So if there's no coupon, bail early and just return 0 instead of trying to do any work. Otherwise, go down and actually do the work. So if we run this code again, run the tests, still green. So this class is looking pretty good, I think. But if we jump into the coupon class, you can see kind of that same shape that we had before. So we can go through and do the same refactoring where we just return early, get rid of the return statement here and have no temporary variables, and everything is still green. Get rid of the else clause since there's no point, since we're already returning, still green. Now in this case, I'm not sure which one of these code paths is a guard clause and which one's not. So I'm just going to kind of leave it like this because I don't really have any reason to, I don't know why this belongs in the conditional versus this one belonging in the conditional. There's no real good logic around that for me, which is kind of a smell in its own way. If we wanted to flip this, we'd have to stick a not sign in front of it and move this up. And now there's like a little bit of extra cognitive overhead in like parsing that conditional. So I think I would rather leave it at the positive case and leave that in the conditional and maybe revisit this later. But overall, things are looking a lot better than they were before. We don't have like a ton of temporary variables. In fact, this class has no temporary variables. The loops are gone. There's only one conditional now instead of the nested conditionals. Every method is one line except for this method here that has the guard clause. The coupon class is the same in the sense that it has no temporary variables, no loops, only one condition. So it's looking a little bit better than it did before. But now imagine a new requirement comes down the line saying that you need to be able to support coupons that give you a discount only if you have at least an X number of books in your cart, right? So all of a sudden you're thinking, how am I going to implement this? Do I have to add another flag? So we have an is % coupon and is minimum quantity coupon, and then we have to start adding more and more conditionals here every time we want to add a new kind of type of coupon. And it depends on different data, so it needs to know the minimum quantity, not just the gross total. So we need a new parameter and stuff like that. And that's just going to bloat up our code and start getting really difficult to understand and difficult to maintain. So you start thinking, well, what can I do to improve this? Beck tweeted this tweet a few years ago saying, for each desired change, first make the change easy, warning this may be hard, and then make the easy change. I thought this was a really powerful idea. Instead of just trying to jam code in and make stuff work, figure out say to yourself, well, if only I could just do this, then it would be really easy to implement this change. Figure out what that if only is, and then reorganize your code so that that is the only thing that you have to do, and then pull that in. And that kind of lets your design evolve over time and kind of stay catered to kind of the needs of your application and how it's changing. So let's talk about how we might do that. So how can we make this change a little bit easier? Well, we know that we're going to need to pass in the minimum or the quantity of books, right? And we don't want this to keep growing and growing and growing. So one way that we can make this change a little bit easier would be to reverse kind of this bit of knowledge. Instead of the order knowing what it needs to give the coupon, let the coupon itself decide what do I need from the order. So if we take just the order and just call a method like gross total on the order. Now the minimum quantity coupon is going to have the opportunity to just ask it for the quantity of books. So this is going to fail because there is no, or sorry, the gross total method is private, and it's also claiming it's because it's an integer, which is because we haven't passed in the order here. But if we pass in this instead of the gross total, make this public, everything should still pass, and it does. The next thing that we can do to make this a little bit easier, I think, is to replace this conditional with polymorphism. So what we're doing here is we're basically checking the type of coupon, right? If it's a % coupon, do this. If it's a fixed value coupon, do that. And we can simplify this a little bit, I think, by creating different coupon types. So let's head back to our tests quickly. And here where we're passing in just a coupon with this is % flag, let's create a whole new type of coupon called a fixed value coupon. We'll save a copy of this coupon as fixed value coupon. We'll update the class name, fixed value coupon, and make sure that we have that imported here. And now if we run this test, everything is still green. But now we have the opportunity to make some tweaks. We can get rid of this is % flag because, of course, a fixed value coupon is not a % coupon. And in the fixed value coupon itself, it doesn't even need to keep track of that anymore because it's never a % off coupon. This conditional entirely goes away. And when we run these tests again, we're still green. We can do the same thing with the % off coupon. So here where we're discounting by a percentage, we can just pass in a % off coupon instead. We'll take our old coupon class and save a copy of this as a % off coupon, rename the class, make sure that we import that here. And now when we run this, if I haven't made any mistakes, we're still green. And now we have the opportunity to do the same thing by removing code that's no longer necessary. So the flag goes away, the other side of the conditional goes away, and this just becomes the default case. And everything is still green, and we can get rid of that here as well. So now if we needed to implement a minimum quantity coupon, I have some tests here. I'm going to go through this a little bit quickly because we're really running low on time here. But all we need to do now is create a new type of coupon that handles this kind of logic. So if we go back to our % off coupon, since we're going to give them a % off if they meet this minimum quantity criteria, we'll save a copy of this as the the minimum quantity coupon. Rename the class. And this is going to take in its constructor the minimum quantity needed to give the discount. And now we need to kind of decide down here, well, if the order quantity is less than the minimum quantity required to get the discount, we'll just return 0. This is going to fail because we don't know the quantity of books in the order yet, but let's just run the tests anyways and let them guide us. So class minimum quantity coupon not found, so we'll import that, run it again. Unexpected syntax error, semicolon, minimum quantity coupon line 10. We're line 8. Writing too many other languages lately. Cool, so I'll call the undefined method quantity. So if we go back to the order now, we can add this quantity method. Let's add a public function quantity. That's just going to return the number of books, right? So we can just return this books count. And now if we run the tests again, we're green. So now anytime we ever needed to add a new type of coupon, we could just create a new coupon class, keep the logic for determining the discount in there, and the existing coupons never have to change, and the order class never has to change. There's a couple more things that normally I would go through and talk about, but we're out of time, so maybe I can point you guys to another version of the similar presentation that I've given where I went into things in a little bit more detail. But hopefully this has been kind of a fun lesson in refactoring, and hopefully talked about some cool, interesting ideas. And yeah, so just to kind of finish it off, lately for me, programming has been all about the little things, focusing on how to make every line of code that I'm actually writing on the screen as good as it can possibly be, not rushing things, not worrying about high-level architecture until I know that the small pieces are kind of as good as they need to be. And by doing that, I'm finding that my code is, a lot more maintainable, and I'm happier with my designs, and I am finding that this kind of nicer architecture is sort of bubbling up from it because I'm not just like being sloppy with the low-level stuff and have my head in the clouds with the high level stuff. So if you've been kind of intimidated thinking about like, how do I follow all these high level best practices and build the most perfectly architectured application, I would recommend kind of taking a step back from that stuff for a little while and focusing on kind of the small pieces and kind of mastering the object-oriented fundamentals and stuff like that. And I think you'll find that as you get better at that stuff, the other stuff sort of starts to come naturally, like Kent Beck said, where it's the same sort of problem solving, the same sort of thinking, just at kind of a different level in the microscope. So if you're a podcast listener, check out my podcast, Full Stack Radio. I've interviewed people like Kent Beck, people like Michael Feathers, DHH, lots of cool people I've been able to talk to about lots of cool topics. It's been really fun. And yeah, if you've enjoyed this kind of refactoring stuff, I actually recently wrote a book and released a video course on refactoring with collections that you can check out here. I'm not going to sell you too hard on it, but if you're interested, check it out. There's a coupon code there to get 25% off for anyone who's at the conference. There's a tiny URL. It's a little bit easier to remember, just tinyurl.com/RFC-EDOC. So refactoring to collections. It should be RTC, but it's RFC in Erie Day of Code. And that's it. So follow me on Twitter if you are interested in this stuff. I'm at Adam Wathen, and I blog about stuff like this relatively frequently at adamwathen.me. Thanks, everyone.